Welcome back, scientists. Today we're going to talk about the rock cycle and the fact that all rocks come from rocks. We're going to start with metamorphic rocks. Metamorphic rocks form when existing rocks, igneous, sedimentary, or even other metamorphic rocks, are subjected to high heat and high pressure, and they cause them to change in structure, but they don't melt. In fact, the term metamorphosis means change, so that change occurs from heat and pressure. Rocks like gneiss, schist, and marble are all metamorphic rocks. Igneous rocks form when molten rock, called magma if it's below the Earth's surface, or lava when it's above the Earth's surface, cools and solidifies. Types of igneous rocks are granite, obsidian, and pumice. The third type of rock is a sedimentary rock. These rocks form with the accumulation and compaction of sediments like sand, mud, and other organic materials, sometimes even fossils. The sediments are often deposited by wind or rain, water, and they accumulate in layers over time. Examples of sedimentary rocks include sandstone, which have sand and pebbles inside them, and shale, which is in layers. So let's go ahead and diagram the rock cycle. The magma is still inside of the Earth. Remember, it's called lava once it reaches the Earth's surface. The crystallization of the magma forms these igneous rocks. So, this is the cooling of the magma that causes the rocks to form. That igneous rock can go under many different versions of the rock cycle. It can immediately melt down in the magma and become igneous rock again. It can weather and erode, go down into the water where it picks up sediments from other rock, compact and become a sedimentary rock, or it can undergo heat and pressure to become a metamorphic rock. Remember, all rocks begin as the molten lava and flow through the rock cycle. Finally, we're going to talk specifically about volcanoes, their forms, and the lava from within. First, we have shield volcanoes. These are broad, dome-shaped, gentle sloping volcanoes. If you were to take a drone and fly it above a shield volcano, it would look like a warrior shield lying on the ground. Examples of shield volcanoes can be found in Hawaii. Mauna Loa and Kilauea are two shield volcanoes. Next are composite volcanoes or stratovolcanoes. These have a conical shape and oftentimes are symmetrical. They're tall and have a layered structure because they have alternating eruptions of lava and ash or other volcanic materials. Examples of composite or stratovolcanoes are Mount St. Helens, Mount Fuji, and Mount Vesuvius. Finally, we have cinder cone volcanoes. Cinder cone volcanoes are the smallest and simplest type of volcano. They have steep, straight sides and a bowl-shaped crater at the top of the volcano. They usually appear like small hills or mounds. Cinder cone volcanoes are moderately explosive and typically have short-lived eruptions. Now let's compare the three types of lava found within these volcanoes. A shield volcano has basaltic lava. It has a very low viscosity, meaning it moves rather quickly and has a high temperature. Basaltic lava is typically found in shield volcanoes. It runs out very liquidy, it cools, creates the shield design, hardens, and then does it again. It's at a very high temperature. Andesitic and rhyolitic lava has an intermediate to high viscosity, meaning it's thick and chunky. It is sticky and has a lot of rocks in it. The temperature is much lower. However, that low temperature causes the gases to build up and a huge explosion. In summary, there are three types of volcanoes that have very different shapes, magma flows, and eruption styles. The shield, which is large, low viscosity lava, high temperature, then composite, which are the steep and very explosive, the cinder cone, which are small, single vent, and moderately intense eruptions. Those two, composite and cinder cone, characterized by the andesitic and rhyolitic lava, which is thick, sticky, full of rocks, and high pressure. These are our explosive volcanoes.